Okay, perfect. Let me know if you can see. Perfect. Okay. So let's kick this on. So road to DevOps, are we ready for transformation? A quick introduction from my side. So Mustafa Toroman, I come from Sarajevo, Bosnia and Herzegovina. I work as a solution architect for a Danish company, Cloudion, which is recently part of DevOps team. But I've been working with US companies. I've been part of the authority partners from California for almost 6 years, and been working with enterprise companies in the United States. I've been Microsoft Azure MVP for 6 years, C# Core MVP, DevOps Institute ambassador, Microsoft certified trainer, so on, so on, so on. Here is my Twitter handle. If I can help you in any way, if I can assist you, answer a question or anything else, feel free to reach out. And let's get this rolling. So how did we deliver software in the past? What did we need to do to deliver software? How did it all started? So long ago, we had something like this. We actually had punch cards. This is something I didn't actually use. I know of, but I didn't actually use. I'm not that old. But this was kind of the first way to deliver software. Afterwards, we got these guys. We got disks that had a small capacity compared to what we have today, but were an amazing improvement compared to the punch cards. Somewhere down the road, okay, just one digression. How my generation looks at this, we see this as something normal, but new generations actually think that's basically not a thing. It's a 3D print of a save icon, but it just shows how much software industry and IT in general progressed. And somewhere down the road, we got actually computer magazines, and the way computer magazines deliver software changed over time. First version, one that I actually used, was that the code for the game or the app was actually printed out. So what you actually needed to do was type it in, compile the code, and then run it. That was kind of a great thing for software developers to practice, to learn stuff, because you actually needed to type in everything, not just read to the code or copy paste it as we can see it today. Then computer magazine started introducing disks, and then down the road, we got these guys. Optic Media gave a great improvement in capacity and how big our software could be. But this was still a physical thing. What we needed to do here in any of those, we had to have physical access. We had to deliver software physically. We needed to get to that location somehow to actually install something. A big game changer in the software industry was web. Suddenly we could do everything over the internet. We could sell our software over the internet. We could deliver updates this way. This was a great improvement. It changed a lot of things and pushed software industry in a completely new direction and gave it wings. It gave it wind and back. Next thing that we had was cloud. Now, cloud introduced a lot of different things and a lot of improvements, and it became much easier to run things. Primarily, and what we are seeing in this slide, cloud offered several computing models. So we had infrastructure as a service, where we didn't care about certain hardware elements anymore. Then platform as a service, that was even easier to manage. But the last component, software as a service, part of the cloud, was the new big game changer. All of a sudden, everything in software industry changed. We didn't deliver packaged software anymore. With software as a service, we changed how we think about our products. One of the great examples that I like to give, but it can be applied to many, many different products is Microsoft Office. We had packaged Microsoft Office for many, many years. A lot of people use that, a lot of corporations. And what we had was a specific version of a software that was crafted over time, then delivered. And it brings two big changes in the software industry. First one is how we purchase the software. With packaged software, we would make an investment. We will buy the package, and especially if we are looking for a company perspective, when we are buying big number of licenses, we are making a big investment. So even if we are not 100% satisfied with what was delivered, we already made an investment. We are kind of stuck with the product and have to use it for quite some time. From perspective of people developing software, it was quite a challenge to create a product that changes every several years. And here's why. So let's say that we are delivering packaged software this year. In 2021, we delivered new version, and immediately we are starting to work on the second one. So as soon as we start, we need some kind of plan. We need an idea on how we're going to do things around that software. What is our final goal? What we want to deliver? And we're going to deliver final product in 2, 3, 5 years. And it's quite hard to predict what kind of the market we can expect down the road. Like what's going to happen in 5 years? Is this what we're developing today, what we decided to go with today? Is it going to be relevant in 5 years? Are we delivering something that's going to be interesting to people? Is it going to have its market share, or are we going to drop completely? So software as a service completely changed that in several ways. First of all, there is this new way of purchasing software, which is subscription. We are not anymore constrained by big investment upfront. We are paying month by month for what we're using. This gives us flexibility from a user perspective, a lot of flexibility, because we're using a software, we are not completely satisfied with it, or we know that there's something better on the market. We can just cancel subscription and buy a new one, buy subscription for a new product that is better suited for our needs, that it's giving us new functionalities, new features that are really exciting that we want to know of. Now, this puts a lot of pressure on software developers, on software development companies, because they are make this approach, how to put it, it makes us be better. We have to be better. Because if we drop the ball for 1 second, someone's going to beat us to a punch. No matter what software we are developing, no matter what market we are targeting, it can be a very niche group, something that we are only doing at a time. But even if we are only company offering something unique, it's not going to be like that for a very long time. We are going to have competition eventually, and this competition is making us be better. Software as a service forces us to make better software, make improvements all the time, and continuously improve. So there are kind of challenges and issues that we might encounter in creating good software and delivering us to our clients. So first of the issues is everlasting struggle between development and operations. I've been in this mess for years, and I've been on both sides of the fight. And what we are seeing constantly when we are discussing development operation in traditional organizations that are still not practicing or even not considering DevOps, is that there is this wall of confusion, constant wall of confusion between two sides that don't understand each other. Essentially, what happens is that development won't change, want to do improvements, and on the other side, operation is all for the stability. Developers want to use latest frameworks, latest tools, On the other hand, the operations wants everything to be stable, nothing to change. Everything needs to be tested for years before approved, and so on. So in this traditional IT atmosphere, we have a major problem. Why we have a problem? Because it's us versus them story. Depending on which side you ask, depending on who you're gonna ask about where the problem lies, it's always gonna be the other side. I don't know how many times I heard it works on my machine from development side, of course. So when there is an issue, it's always gonna be it works on my machine. And there's a joke about it, like there's then we ship your machine, and that's how Kubernetes started out. But on the other side, if you ask when there is an issue, if you ask the operation, what's the problem? It's never going to be this problem on the server. It's going to be code. But we have these gray areas as well, like in these situations. Software, for some reason, we cannot push forward, we cannot deliver, or something is not working. So, for example, if 6 days after successful deployment, all of a sudden we have high load on server, who needs to check out what's going on? Who needs to take ownership of the problem? Well, it really depends on who you're going to ask. If you ask development, they're going to say it's a server problem, they need to fix it. If you ask ops, it's obviously code, their server is fine, it was working fine before they deployed something, and it's always the code. So in this situation, we have this blame game, and as the end result, problem is not getting solved. We are in a situation that it still doesn't work. Customers cannot access our software, and no one is actually taking ownership, no one taking responsibility in solving the problem. It can be similar examples like if after deployment software, recent deployment, we cannot log in, who needs to address the problem? Or there's an issue with this build server, who needs to resolve that? It's always going to be the other side. There's no definition on how to resolve certain issues, and that creates a major issue when we want to run a successful software company and have a product that customers want to use. Because who wants to use a software that isn't available, that cannot be run? No one. So big problems in DevOps today. So there is no formalized handover between teams. Like there's no a clear line of responsibility, who takes ownership of what. Operations is always going to face problems in the production, while developers will never have knowledge of what's going on in there. That's another like approach that we see in traditional IT environments, where development will work on something for quite some time, then say, okay, this is done, and just throw it to operations. What we have in this situation is neither side knows all the facts. Developers don't know, development team doesn't know where it's going to run, what is their environment, are there any special requirements, and so on. Same for the operations. They have no idea what's around that code. Does it require certain frameworks, certain special settings? They need to figure it out. So it's a really bad situation. Again, what we already mentioned, we have those silos, isolated work, we, they, us versus them. It's a complete mess. We mentioned that developers want new things, they want shiny new toys, they want to experience latest frameworks, latest tools, where operations is trying to ban everything that is not tested and completely stable from their perspective. But there are other problems, like they are using different tools. There's complete disinterest on what the other side is doing. We don't have clear environments. Like for successful development, we need clear environments, and environments should be in line with one another. We have this blame game, and at the end of the story, we have different processes. It's rarely going to happen that development and operations are using same process. For development, it's very often going to be Scrum, where operations are usually on idle or Kanban or something similar. So usually processes are completely different, and that creates additional issue when communicating with one another. Now, solution for this, of course, is bringing those sides together. It's DevOps. Now, DevOps is basically describing development and operations working together, working as a single team, not creating these silos, but bringing them closer together, making them communicate, and trying to have a common goal. Like our final goal should be good software available for our customers and satisfied customers. And DevOps main goal is exactly that. If there is really hard to put a definition on DevOps, if you ask 100 people what DevOps is, it's always going to be a different answer. One of the answers I really don't like, what I've seen in the past very often is that answer for companies to start doing DevOps is to hire DevOps engineers. First of all, I don't like the title of DevOps engineer in general. I think it's impossible to be a DevOps engineer. The name for itself says like we have a dev and ops. This person should be equally good at everything. Should be a really good developer, should be good, really good operations engineer, and they should be able to solve any kind of problem wherever it is. That's not feasible. That's not possible, simply. What we have in these kind of situations is that when I talk to people that are DevOps engineers by title, their company calls them DevOps engineers, it's always going to be operations engineer that knows how to write automation scripts. Like 99 times out of 100, it's going to be something like that. And the point is, there is no doing DevOps is not putting a DevOps engineer in your team. But basically, what you're doing right now, if you're trying to do things like that, is you have dev, you have development, you have operations, and you're putting DevOps engineer in between. You're making in another layer. Somewhere there, that's even so these people are going to communicate even less because they have a filter in between right now. Well, the closest to accurate definition of DevOps is one that I've heard from Donovan Brown from Microsoft, is that DevOps is union of people, processes, and products to enable continuous delivery of value to our end users. And I think that's the complete point of DevOps. It's designing something for us and having satisfied end users as an end result. That's the main purpose of DevOps in general. So what is exactly DevOps? So it's not basically, it's like the definition says, it's union of people, product, and processes. Hiring a DevOps engineer will not solve your problem. Starting using new shiny thing is not going to solve your problems. You're not DevOps just because you started using, I don't know, Git or Jira or Jenkins. That doesn't solve anything. Primarily, DevOps is a new culture and a new way of thinking. You have to change your approach in general on how you're doing things if you want to have a smooth and good quality transition. First rule of DevOps is try to automate everything. Everything possible should be automated. Reason why we want to automate things is because we want to minimize mistakes. We are minimizing mistakes by removing manual steps, because when people are doing things, like when we are, for example, if we are deploying software and we need to deploy a new version to several servers and stuff, if you're doing it manually, this will require someone to go in, change configuration files, copy some settings or something else. And even if person knows exactly what they're doing, if they are doing it multiple times on multiple environments and stuff, it's always going to break somewhere. someone is going to copy something in a wrong place from a wrong environment, provide a wrong connection string, and something's going to break. So we want to avoid situations like this by automating all possible steps. It's not possible to automate everything 100%. And in my opinion, there always should be a part of human interaction in the process, but we want to automate as many steps as possible. In this automation process, there are a couple of things. Everyone knows of CICD, and basically what CICD stands is can differ. It can be two different things. CI part is always going to be a continuous integration. So this is part of verifying your code and seeing if that part, if it's going to build and if possibly tests, recommendably tests would pass. But then for the CD part, we have two different options. It can be either continuous delivery or continuous deployment. With the continuous delivery, we are making software ready for deployment. So basically, we are putting everything in place, and then someone from the business side decides when this is going to roll out. Personally, preferable option in most of the scenarios. There are kind of like exceptions where you want to remove that part as well. But in most of the scenarios, I prefer continuous delivery because it holds you in control at up until some point. On the other side, continuous deployment is basically pushing everything automatically. From the moment developer commits code to the repository, everything is automated. We are doing builds, tests, deploying to multiple environments, and if everything goes according to plan, if all tests pass, then the code is going to end up in production. This part is completely automated and there is no human interaction. Okay, so when we look at the deployments and how companies do things, this graph is, I think, like 2 or a little over 2 years old, and we can see how certain companies do deployments. For example, when we look at the Amazon does 23,000 deployments per day. So what do you think? What do they use? Continuous deployment or continuous delivery? Well, obviously, in this situation, everything needs to be automated. You need to have a situation where everything goes from one end to another completely automated. If all the checks and all tests are completed successfully, then it's going to end up in production. And having 23,000 deployments per day is kind of crazy and sounds a lot. But some other companies like Google does 5,500 deployments per day, or Netflix does 500 per day, and Facebook 1 per day. We need to understand that all those deployments are not major changes or something change breaking or feature delivery and so on. These are usually small changes like fixing a button, adding a photo, changing font on something or whatever. But basically, a lot of these changes, majority of these changes are very, very small changes. And then when we go look at these, let's call them modern companies that are leading tech industry today, and we compare them to typical enterprise, what we have is that we are having a deployment every 9 months. I've been working in such environments for quite some time, and there are many, many challenges in situations like that. The biggest problem is the amount of changes you are delivering at once. When we look at the Amazon and their 23,000 deployments per day, these are going to be very, very small incremental changes. What happens is that basically someone noticed that there's an issue with the button, and they're going to fix the issue immediately. And as soon as that one is like resolved, they're going to push it to production. And what happens, even if there is an issue, We have so small code base, so small code change that happened during this deployment that it's really easy to pinpoint where the issue is, to fix it and roll out the fix. On the other side, when we look at the typical environment, typical enterprise, where we have deployment every 9 months, what happens is we have usually in an enterprise large teams that are delivering something. So if you look at the team of 50 coding for 9 months, can you imagine the number of lines of code that's gonna be there after 9 months of development? 50 people writing code for 9 months. It's going to be insane number of things. It's going to be big numbers of features, major changes. First of all, what will happen is that you're probably going to have a bug somewhere. Out of 50 people writing code for 9 months, issues are going to happen. There are going to be bugs. They might not be major bugs, but there still be bugs. First of all, what is happening here, it's really hard to roll back to a previous version because you're removing a large chunk of features. Especially you're going to have a really dissatisfied users because you are removing a big number of new changes, like some things that people are really excited are shown to them. Someone discovered a bug, now they're gone. The other part of the problem is how much time is going to take us to fix a bug, first of all, to find where bug is in code that was delivered by 50 people in 9 months, then fix that bug. And it's going to be more of them, of course, not a single one. So fixing those changes, fixing major changes take quite some time compared to small increment changes. What we have in project execution methodologies, like most of the companies that I've worked previously with, were either on Waterfall or Agile. So they are kind of similar. There are little differences. So for each of them, at the beginning of the process, we're going to do design. And in Waterfall, we're going to code everything. Once everything is coded, then we're going to test it. And after tests are done, we're going to deploy that. In Agile, what we have is each segment, each separate component is going to be coded and tested. But again, we are going to deploy at the end of planned period. It can be, I don't know, depending on how you do things. It can be 3 weeks or a month or 6 months, whatever. But deployment is always going to happen at the end of a certain period, agreed target time. What we are introducing in DevOps is continuous deployment. We are constantly rolling out something. Every small piece of code that can be looked at as a standalone, something that is a standalone change, is going to be developed, tested, and rolled out immediately. So we are deploying everything as soon as it's done. Take, for example, Amazon, 23,000 deployments per day. Each change, as soon as it's verified, as it's tested, it's been rolled out. This is the part of this software as a service mindset when we are constantly improving something. If we are fixing a bug or adding a small change, and we can do it relatively quickly, and we can do it efficiently, and it's going to improve user experience in some way. What we want is to roll it as soon as possible. So why wait month or 3 or 6 or 9 to actually deploy that? When we complete the change, we are testing is everything going to run fine? Is everything fine with these code changes? Once we verify that, we can roll it out. We can deploy it immediately. So this is like a major change in this.
There was a question in chat, if I may.
Okay.
And it says, does this happen in production hours or after production hours?
So this is like the that part of continuous delivery against continuous deployment. So one is going to be automated all the way, like everything. Like the moment I commit code into repository, everything is automated, and there's no like scheduling or thinking when it's going to happen. Like once I commit that, it automatically triggers continuous integration. It's going to build, it's going to test, it's going to deploy to multiple environments, run some additional tests. If everything passes, then we are going to have deployment to production. No matter what time it's completed, no matter what kind of change was made. On the other side, that's again comparing continuous deployment and continuous delivery. The part where I like human interaction, where business is deciding when something is going to go. In that approach, we are just making changes ready. Now, like every change that we are doing, we're making it ready. We are making it ready for release. Everything can be, once we complete some piece of code, it can go to production. But in this particular case, we are choosing when to go. In my personal opinion, and from my experience, this is much better approach because we are controlling completely the time frame, especially for smaller changes. This can be probably done quickly. It's not a major change, so it can be rolled out very fast. Deployment is not gonna last for very long. But when we are looking at the major changes and bigger things, we probably don't want to do this during business hours, or maybe it's okay to do it during business hours, but do we want to do it during peak hours? If we are developing software for fast food delivery, we probably don't want to roll out new feature around lunch where everyone is ordering things. So basically, it really depends on, are you practicing continuous delivery or continuous deployment? So that's the big difference. Okay, I hope that answers the question. Anyway, so how the DevOps looks like? So basically, DevOps is never-ending cycle. It's continuous improvement. We are constantly trying to improve things. So at the beginning of process, let's call it sprint or whatever you want, we're going to have a planning. We want to decide what we're going to deliver in next period. We are starting to develop that and what was planned, and we are developing and testing. As soon as we are tested something, we are ready for release. Once its release is ready, we are pushing that to production. And usually this is where things in traditional IT stop. But in DevOps, we are just getting started with everything. What we want to do is monitor and learn. We want to observe what's going on with our application. And then based on that, based on knowing what is going on with our application right now, we are starting the process again. We are monitoring, we are learning from what's going on. And according to that, we are creating a new plan how to improve things. What's very important that this is not traditional IT monitoring for availability and performance. Of course, these are still very important things. First of all, application needs to be available at all times. If software is not available, it's no good to anyone. Second part is, of course, performance is also equally important. But in DevOps, we are pushing this monitoring part much more further. We are trying to monitor for all possible metrics. We want to know about our user behavior. Like, when people visit our web application, for example, what pages do they visit mostly? If we rolled out a new exciting feature, we really are proud of something we built and no one uses it. We want metrics to tell us why. Are people trying it out and they are not satisfied and not using it, or we hid it somewhere in the menus and people are not even aware of new functionality? These things in production we want, so basically, to select as much metrics as possible, so to learn from these metrics and create new plans and continue improving our software. One of the things that this approach is giving us is increasing feedback. The faster we push to the right, the faster we get feedback to the left. So basically, once we develop something, let's say I'm developing a new thing, I'm developing a new feature, and I'm working on the code for quite some time, and it's just gonna sit there. and someone is going to collect all the changes and then try to push to different environments and start testing. But if I push my change immediately, if I created a change, I completed my feature and pushed it to dev environment, and I ran some tests, and I noticed that I failed. I want to know that as soon as possible. I don't want to know in 3 months that feature I developed is failing. I want to know while it's fresh. It's two perspectives. It's good from two perspectives. First one would be that I know as soon as I did it because it's still fresh and I can easily return to fixing that thing. And the second part is once when I know that something is wrong at the end of the 3 months, release is coming up and there's a lot of pressure to fix it as soon as possible. The other part is as soon as we push something to production, we can start learning and planning for improvements to basically learn how we can make our software better. The other part that is quite big in DevOps is constant experimentation. We need to experiment even if we fail, but this is how we're learning. Again, this is this feedback loop and DevOps cycle that's never ending, and we want it to run as fast as possible. So we are planning something, we're thinking about certain things, we try it out and then decide, did it work? If it worked, good, we learned something, can we improve it, and so on. If it failed, again, lesson learned, but can we make some changes and make it still work, or so on. It's all about experimenting and getting the feedback from our experiments as soon as possible. Again, increase feedback, getting information from right to left as soon as possible. Some of the project management best practices, we need to use same tools as a team. It's no good for anyone if development is using certain things and on the other hand, operations are using something totally else. We want to use same things. We want to treat everything together as a team. We want to be on the same page. Also very important in the DevOps mindset is to define MVP. Minimum viable product is very important to define. Done is better than perfect. Like, what is the effort? Sometimes I'm gonna complete something, 99% of something in 2 days. And then for that 1%, I have an idea, I need to do something, but for that 1%, I'm gonna spend a couple of weeks and still can't get it done completely right. So we need to define when things are done. We need to define what is MVP for us and what can we actually roll out. How to apply this to our organizations? We need to start small. Just deciding, okay, from Monday, we're gonna change everything and we're gonna do DevOps and it's gonna be amazing. That's gonna fail from the very beginning. It's gonna fail magnificently. The issue here, when you're trying to force big changes on people, they are going to resist it. So what you want to start small and you want to prove value of the changes to people. So if you introduce a small change that no one is going to be bothered with, basically what you're getting is you're giving yourself an opportunity to show people the benefit of that change. Once they see the benefit that something is better or easier, then they are going to accept the next change and the next one and the next one. So start small and try to fix like provide certain benefit and make it easier for the people. Automation is a must. Try to automate as much as possible. It's also important that this is a cultural change. Always remember that it's cultural change, and it's also organization-wide. Starting with a tech team, like starting with development operations when implementing DevOps, it's always going to fail as well. Why? Because organization as a whole needs to accept a DevOps mindset, DevOps culture. If management didn't accept it, if marketing is not working according to DevOps, finance, everyone needs to change their mindset and accept DevOps as a culture inside the company for this to actually succeed. If management doesn't understand DevOps, but trying to force it down, it's going to be fail again, because it needs to be company-wide change. Every win should be recognized as a team win, not a personal or individual win, but everything that is completed is a win for everyone involved. And basically, very important part, create common outcomes and have dashboards. Have ways to track how things are going, have an insight on how things are developing, are you on track with things, and have strictly defined goals that you want to complete on time. Thank you for your time. I don't know if we have a little more time, so are there any questions?
Looks like we have a question for slides.
Mm-hmm. Hey, this is great.
Sure.
Can you hear me okay?
Yeah.
Mm-hmm. Oh, great. So I had one question. You talked about after it's released that the monitoring phase is a lot deeper than probably what most normal dev teams do. It's beyond availability and performance. You said even tracking things as deep as page views and how the customer's actually interacting with the product or feature that was released. So is that the dev team, the actual people that did the coding doing that, or is that normally more the people on the operations side that kind of take that and track that?
Basically, again, it's a joint effort.
Yeah.
Both sides need to be aware of things and need to collaborate together. From selecting the tools, because at the end of the day, what's end up in the production, operations team is probably going to be the first response. Like if something goes, operations team is going to be notified that something is wrong and so on. And everything that is strictly connected to production is going to be tied to them, at least as a first response. But this needs to be a joint decision for everything. Like what tools are we going to use? What makes it for us to be efficient? What makes more sense for us? So if we're looking, especially if we're looking at those things like page views and stuff, development team is they're going to know better based on the frameworks and the tools they're using, what's going to work better with the software they're writing. For example, if they are running, I don't know, .NET, it's probably going to be application insights for those kind of metrics. But then again, if we're running something else like New Relic or something else might be a better solution. So it really depends. It's a joint decision. Things need to be agreed, but both sides need to be aware of what's going on and who is in charge of certain things.
Okay, wonderful.